Hello there. Welcome to this video on setting up your ESP8266 Wi-Fi module for test. This is an exciting video because this is a chip which is going to be connecting you to the Wi-Fi and eventually the internet. In this video, we're going to be looking at Adafruit's Feather Huzza ESP8266 module. I'll hand walk you through the module and we'll also set up the Arduino IDE for the module. This is the ESP8266 module by Adafruit and they call it the Huzza Feather because it's very light. It's only at 6 grams and it's quite small. It's only 51 millimeter to 23 to 8. It's quite small. We'll see that in just a bit. The main chip on this module is your ESP8266 microcontroller, which works at 80 or 160 megahertz, and they work at 3.3 volt logic. So that means when you give a high, this chip is going to give you 3.3. So 5 volts may not work here. This ESP8266 chip has a 10 silica chip core and it has a full Wi-Fi TCP/IP stack burnt on it. It has a 4 MB of flash at the speed of 32 megabit per second. It has 9 general purpose input output pins. So right about here, if you see here, 5, 4, 2, 16, 15, 12, 13, 14, all of these are general purpose. It has 1 analog pin right about here, ADC. It has some general purpose LEDs right about here, one which is connected to your pin number 0. So if you want to test your board and things like that, this is your LED to work with. And there's a LED right about here as well, which works for boot loading, debug, and general blinking. Alright, there are also some other options in the market like Node MCU, which is very popular. The Adafruit Huzza has a very similar structure to the Node MCU. So you have your pins here, D0, D1, D2, D3, D4, and so on. So this also works on 3.3 and ground. This also has 9 GPIO pins and so on. So if you want to see how to hook this up, please go to this link. You'll be able to see how to work with Node MCU and the Arduino IDE. We have another option called the WebMOS. This is also very similar to the Node MCU and Adafruit Huzza. This also has the ESP8266 chip on it, but is much smaller in size. Now let's hand walk through the Adafruit Huzza chip. What you're looking at is the actual ESP8266 Adafruit Huzza Feather module, and it's pretty small as you can see. I have already connected this to the USB right about here. Alright, let's go to the main components. The main component here is the ESP8266 chip, which is right about here, and this is the antenna. The other components are really small. I'm going to point out a couple of them. The first one is a chip here, which converts the USB to serial. We have some active and passive components like resistors, capacitors, diodes. Here is your battery charger. So this is where you would hook up your battery if you want to charge it, and then your device will become mobile. The headers are already soldered. You might want to get them already soldered because you don't want to have the headache of soldering. But if you are very good with soldering and you have a specific idea in mind, then you might want to get it without the solders. But I have already soldered my headers, and as you can see, it's very difficult to see the pin numbers. I'm anyway going to take you through them. The general purpose input output pins start from here and go all the way up till here. So those are your 9 general purpose input output pins. Your analog input output is right about here, which is named as ADC. You have a ground, a 3.3 volt, and so on. So these are your main pins. You have your TX and RX here, which you would not really use unless you are really sure what you're doing. Perfect. You have 2 general purpose LEDs. One is about here, which is connected to pin number 0. So if you want to test your Wi-Fi module, you would run the code highlighting your LED connected to pin number 0. You have another LED on this end, which works when you're boot loading, when you're loading a program, when you are doing any general purpose activities on the chip. Now let's hook this up with Arduino IDE, run a basic code, and test if everything is okay. Before actually looking at the Arduino IDE, let's first take a look at the steps you need to do. The first thing is you need to connect your USB between your board and your computer. Once you do that, it will automatically install the USB driver for the CP2104 chip. Once it is successful, then you can add the URL listed here in the additional board manager URL, which is a part of your preferences section. Don't worry, I'll show you this. Once you're done, then you can create a new file. You can go to your select boards and choose your Adafruit Huza board. Select your frequency, baud rate, the active COM port. That's it. Voila, you'll be all ready to go. Now let's take a look at this in action. Now the first thing is I'm going to be inserting this USB in my computer, so you can see the lights glowing just for a bit. So that was your indication that now your USB is actually connected. Alright, perfect. Now I have already installed the driver, so therefore you're not seeing any indication. Generally you would see a pop-up here showing that your driver is being installed. Perfect. Now if you go to the file and if you go to preferences, and you can find your additional board manager URLs. So this is where you're gonna punch in your URL. Alright, once you do that, you can go to tools, you can go to your boards, and you can select your Adafruit Huza ESP8266 board. You see that you have other options as well. Alright, once you do that, you can check your CPU frequency. We're going to leave it at 80 megahertz. You can check your upload speed. So 115/200 is good for now, and you can select your active COM port. Alright, looks good. Now we're all set, and now let's go ahead and write a sample code. This is going to be very similar to what we did before. A quick run through real quick is we are initializing the pin number 0 to output, and then we're writing high, giving a 1 second delay, and then writing a low. Pretty straightforward. Alright, let's go ahead and compile this and upload it. You can also directly click on upload, because first it compiles anyways and then it uploads. Alright, now let's give it a second. Okay, now it's uploading. As you can see, the light is glowing. It takes a bit longer to upload the code compared to your Arduino Uno. Alright, now the loading is complete, and now you can see that the LED connected to pin number 0 is glowing high and low with a 1 second delay. Voila. So congratulations, now your Wi-Fi module is ready to be connected to a Wi-Fi network. In the next video, we're going to test this Wi-Fi module and connect it to a Wi-Fi network. Thank you.